Hello, welcome back. Today let's solve Leetcode problems, keys and rooms. Okay, so the problem is we have n rooms and all rooms are locked except the first room. So our goal is to visit all the rooms. Okay, and we cannot enter a locked room without having its key. And when we visit a room, we may find a set of distinct keys in it. Each key has a number on it, denoting which room is unlocked, and you can check all of them with you to unlock all the rooms. Okay, makes sense. And we have an array of rooms. Okay, so where rooms are in a set of keys that you can obtain to visit the room I. Okay, so we need to return true if we can visit all the rooms and false for otherwise. Okay, and okay, so let's check for the first example. For example, we have okay, so the room 0 we can always it is always able to visit, right? So and then we can visit the room 0, and then in the room 0 we can collect the key to unlock the room 1, and then we can use that key to unlock the room 1, and then in the room 1 it 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 has the key to unlock the room 2, and we will use that key to unlock the room 2 to get the key to unlock the room 3, and then as we have and then we can able to access the room 3. Okay, and as there are no more rooms left, so we can return true as we can able to visit all rooms, right? And then okay, for the example the room 0 we can have the key to visit the room 1 and room 3, and then we can able to visit the room 1, right? because because we already have the key to unlock the room 1 in the room 0 already here. Okay, we can visit the room 1, and then we can collect 3 keys to unlock the room 3, room 0 and room 1. Okay, but we cannot visit the room 2 since we don't have the key to unlock that room. Okay, uh, okay, and well, for this problem okay, so let's try to draw it. To see if we can think about any possible solutions, right? Okay, so for the first example as we can always can visit the room 0, right? Okay, and then for other rooms that we can unlock from the room 0, we can connect it to the room 0 as a graph. We can represent the rooms, we can represent the whole rooms as a graph because it looks very similar, right? For example, we have the room 0, and then in the room 0 we have the key to visit the room 1, and then it means 0 will connect to 1, and in the room 1 we have the key to visit the room 2. It means 1 will connect to room 1 will connect it to the room 2, and same with the room 3, right? Same with the room 3. and then for the room 3, no key in that room, so that's fine. Okay. Okay, and let's check for another example. For example, we currently in the room 0, right? In the room 0, we have the key to visit the room 1 and room 3. It means 0 will connect it to 1 and 3, right? And then for in the room 1, we can able to visit the room 3, room 0 and room 1. It means one can connect to 3. Okay, one can connect to 3, one can connect to 0. Okay, already have the connection, and one can connect to itself, which is 1. And then in the room 1, okay, and in the room 2, we can only visit itself. It means there is no connection to the room 2. Okay, and for the room 3, we can able to visit the room 0, which is 3 will connect to 0. The connection is already exists, right? Okay, and what do we say? Well, do you remember the problem number of provinces? That's already there in my channel. Okay, so it means we can consider. I think that the solution is exactly same as the problem number of provinces in my the previous video on my channel. Okay, in this problem we can consider for each room is one city. Okay, and then we will find all possible provinces in the graph. It means we will need to count all connected components in the graph that we built here, and then if okay, solution is let's write down, right? Okay, so the solution, first we will count number of connected graph. Okay, we can count it as count, right? And then we will check if count is 1, it means we can return true, right? Okay, and else we return false. So that's all for the solution. We will count all connected graph, and if there is exactly one connected graph, it means we are able to visit all rooms, else we are not able to visit all rooms. So for example, for this example, right, we have how many connected? We have 2, right? This is 1 connected, and this is 1, another 1, so we will return false. And for this one, right, we have only 1 connected graph, so we will return true. Okay, and for the implementation, okay, very similar with the number of provinces. We will try to apply the deep first search algorithm on each room. It means we will try to visit all rooms using the deep first search. So when we finish the default search on every rooms. So we already we can already have the connected graph, the connected components of that room, right? And then we can count it, and then we will check it if it is one. So that's all. Okay, let's try to code. Okay. Okay, so let's declare a boolean array that represent for the visited. It will equal to new boolean rooms dot size. Okay. Okay, and then we will try to DFS all rooms. For in room uh, room 0, room less than room dot size, room plus plus, and then if dot visited room, we will try to DFS the rooms visited and room. Okay, and then let's declare the number of connected rooms. First of all, it will set default to 0, and then after we DFS it, we can increase this number, and then if we notice that the number of connected rooms is greater than 1, it means we can directly return false, right? And finally we can return true. Okay, as the number of connected rooms is now is 1, which is we have only one connected component, right? It means we can return true. So now the problem now is we will need to implement for the default search algorithm, right? So let's do it. Default search list of list integer rooms boolean visited and in room. Okay, so we will put the current room into a stack. Okay, stack dot upper plus room why not why dot stack is empty. What we do, we have the current rooms is stack dot post first. Okay, if we already visited the current room, we can skip continue, else we will set the visited at the current room to true, and then we will try to add on adjacent rooms on adjacent rooms to the stack. It means we can add on keys that we can collect in that room to the stack. Okay, for key in rooms dot get current room. Okay, so we will push them to the stack of the first key. Okay, so I think that's all for the implementation. Let's try. Okay, looks good. Okay. and try to submit. Okay, accept.